This video is about finding exact arc length. Now, we've already learned this, okay, that we have this thing called the circumference of a circle. And remember, the circumference of a circle is measuring around the rim of the circle, okay? That's called the circumference. Now, within a circle, we've got a center, and oftentimes we're going to have a radius, okay? And one thing that we learned about circumference of a circle was we said the radius, we want to take the radius and we want to find the diameter, which would be 2 times the radius. And then we learned that the circumference of a circle was equal to d pi, or diameter times pi. Okay? So based off of this, what arc length is only finding a fractional part of that rim, a fractional part of the circumference. Okay? So the way that this is set up is, let's say, for example, that we have a radius like this, okay, in a circle. Well, we're also going to have another radius in this circle that causes an angle to be formed. So let's call that angle a Greek letter known as theta. Now, theta is like I said, the angle measurement. And this we learned because it's a central angle, that the angle was equal to the intercepted arc. So in other words, if theta was 50 degrees, the arc would be 50 degrees. What they want us to actually find here is how long is it? So if you can imagine kind of taking that arc, that rim of the circle, and stretching it straight out, what would it measure? And we have a formula for that, and that's the formula that we're going to be focusing on today. This formula is known as arc length. I'm going to abbreviate it as AL. And arc length is a fractional part of the circumference. So it's going to be theta divided by 360 times d pi. And one thing that we're going to focus on today is how do we find the exact measurement? And what that means is we're going to leave pi as a symbol, okay? We're going to leave pi as a symbol. So this theta over 360 gives us the fractional part of the circle, and then we multiply that times the circumference. So we've got just a few examples here. Let's see how it works. Okay, in the first one, they tell us a couple of pieces of information. They tell us theta is 60 degrees, and they tell us that we have a radius of 10 kilometers. The first thing I want to do is change that into a diameter. Now I know that the diameter is 2 times the radius, or the diameter would be 20 kilometers. Okay? I then go to my arc length formula, and I say 60 over 360, theta over 360, times d times pi. And then we're going to label this kilometers. All right? Now, my job now is I have to clean this fraction up. Okay? So there's a couple of different ways that you could do it. One way would be to take 60 times 20, get that answer, and divide by 360. But the problem is that's going to give us some long approximated decimal in this case. We don't want an approximated decimal. So what I have to do is I have to simplify the fraction. All right, so if I've got that 60 times 20 again, I know that that's saying 1200. All right, so my arc length would be 1200 over 360 pi. But now I need to simplify that even further. Well, I know that 1200 divided by 360, I can simplify that to 120 over 36 pi. And I know that I can take 6 out of both of those. So that would give me, let's see, 20 over 6 pi. And I could still simplify that even more by dividing both by 2, and that's going to give me an arc length of 10 thirds pi kilometers. My final answer has to be a simplified fraction with pi in the answer. Okay, so let's try another one here. Let's say that they give us that the radius is 13. First thing I want to do is say that the diameter is 2 times the radius, or 26. All right, I'm going to use my arc length formula, which says what is theta over 360, or the fractional part. So I'm going to say 240 over 360 times d pi. All right, and then don't forget we got to label that at the end. Always label arc length. Okay, now I'm going to do this one just a little bit differently. I'm going to simplify that 240 over 360 first. I can do that. Okay, so I know that my arc length, let's see, I'm going to make this 24 out of 36. All right, times 26 pi. And let's see, 24 over 36. I know that 6 goes into both of them. How about 12? So let's see, that would break down to 2 thirds times 26 pi. All right, and now the arc length here, let's see, I would have 52. 2 times 26 is 52 over 3. All right, does 52 divided by 3, does that work at all? Is there any way I could simplify it? No. So that's going to be 52 over 3 pi, and then my units here were feet. So one way that they can give us problems involving arc length is they give us the information of the radius and theta. The other way that they could give it to us would be in a picture. All right. In this picture, here's what I know. I know that theta is 45 degrees. I know that the radius is 12 yards, which means that the diameter must be 2 times 12, or 24. I take that information, I go to the arc length formula. Arc length is 45 over 360. That's the fractional part of the circumference, times d pi. And again, don't forget to label this. Now, 45 over 360 can simplify pretty easily. If you look at that breaks down to, because 45 goes into 360, this is going to give me an arc length of 1/8 times 24 pi, which would be 24 over 8 pi. But I can simplify that arc length as well. 24 over 8 tells me 3 pi. Now bring in the units, yards. So sometimes they're going to simplify to a nice even number, okay, a nice rounded number, or a perfect number. And sometimes you're going to end up with the fractions like we did in the first couple of problems that we saw. Okay, let's take a look at this one. Now notice in this one, theta, the darkened part of the arc, theta here is 210. All right, I know I have a radius of 14, so the diameter is 2 times 14, or 28. Once I have that information, I'm ready to go to the arc length formula. And that says theta over 360 times d pi, 28 pi. I'm going to simplify 210 over 360 to 21 over 36 times 28 pi. I know 21 over 36, 3 can go into both of them. So I have an arc length of 7 over 12 times 28 pi. You can tell there's a lot of simplifying that goes on here. So now I'm going to take 7 times 28, and I get 196 divided by 12 pi. And I know I can break that down. Let's see, I know that 2 goes into it. Is there anything else that goes into it? How about 4? 4 could go into it. So I would get an arc length, let's see, 196 divided by 4 is 49. 12 divided by 4 is 3. 49 over 3 pi, bring in the units, meters. All right, take your time on this. There's going to be a lot of simplifying in fractions. Let me know if you have any questions.